Good morning, students. This is your RJ sir. Today we are going to start another new topic, that is chemical bonding. Subtopic is hybridization. Subtopic is hybridization. So today we are going to discuss clearly what is hybridization, how many types of hybridizations are there, and how atomic orbitals are involved in hybridization, and how they are converting into hybrid orbitals, and each atom contain how many hybrid atoms, and each atom contain what type of hybridization in the molecule, and also we'll discuss orbital diagram of hybridization and some examples and some PYQ questions, and also I will ask some important PYQs for you, and you can answer, and also you have to comment on that and tell me your opinion on this topic. Thank you. We'll start without wasting our time. So here, hybridization is nothing but here hybridization. Hybridization is nothing but here intermixing, intermixing, intermixing of atomic orbital, atomic orbitals, and and their their redistribution, redistribution into equal number of equal number of and equal energetical, equal energetical hybridized orbitals, hybridized orbitals, hybridized orbital. This is known as what? Hybridization. See again what is the definition of hybridization? Intermixing. What is here? Intermixing. Intermixing of atomic orbital. Which orbital? Atomic orbital. And their redistribution into, very important point, equal number of, how many atomic orbitals are involved? Equal number of hybridized orbitals are formed, and equal energetical. Okay, all are equal, and will continue. Atomic orbital are converting into hybridized orbital. This phenomenon is known as a hybridization. Clear, student? This phenomenon is known as hybridization. So I will take a best example to understand this one. All of you concentrate. Are you able to see this now? Yeah. Here I will take best example. Actually, hybridization generally we can see in plants and animals. We heard this statement. Hybrid, hybrid tomatoes, hybrid brinjal, isn't it? So, and these things also present in animals. How hybrid buffaloes, hybrid goats. Like this, we can heard some words hybridization. Why we need to discuss in chemistry? So I will take one best example to understand this concept. All of you concept. First, you take in a best example to understand what is the hybridization. Clear, students? What is the hybridization? I take for example for animals. Here, donkey is there. Donkey, right? And we have here horse. Horse is there. What happened between these two? Donkey, we have a special characteristics, that is, you know, special characteristic. It can move very slow. Listen carefully. Move very slow. Donkey can move very slow, right? And it has is another capacity, bear more weights. It can bear more weights. It can bear more weights. That is a best property. This is not a best property. It is a somewhat it is degrade property. This is your upgrading property. So there are two important properties. One is useful, another is not useful. This move slow means not useful. Also, it can bear more weight means it's a good property. What about Rs? You can see. For Rs also we have here two important properties. One is it move fast. It move very fast, not fast. It can move very fast. We know Rs can move very fast. And second one is, yeah, you can see. Second character is very important character. That is, it can bear less weights. It can bear less weights, isn't it? On the Rs we can ride one or two members, not more than this. But we can keep more weights on the donkey. Clear? So now we'll see what is the main important about these two. Why we selected these two, donkey and Rs. We are going to hybridize these two characters. Whatever two characters here, donkey character and horse character. When we are going to hybridize these two gametes, what happens is both will mix donkey plus horse. Donkey and horse we are mixing. Both we are mixing. Donkey and horse we are mixing. Listen here. I will write again. Here we are mixing both characters are donkey and horse. Okay, students. What happened? Here we'll get here very important character. Very important character is it can move very fast. It can move slow and it can move very fast. Which is desirable. This is desirable. Okay. So in this it can bear more weight. This can bear less weight. This is not desirable. This is not desirable. We can add these two desirable characters. What happen, we'll get here whenever donkey and four gametes are mixed, we'll get here mule. Mule will get. Okay, we can see like a zebra it is. So this is a son of daughter and horse. We'll get here mule. What are the characteristics of this mule? So both characters. Mule has similar to donkey. It is donkey, and it has here horse characters. That means it can move very fast like a horse. And one more thing, so it can bear more weights. It can bear more weights. You can see both characters are there here. Both characters are there here. That is donkey and horse. So this is called here hybrid of hybrid of hybrid of donkey and horse. This is the meaning of hybridization. Okay, sir. Got it? What is the hybridization? So, whenever we are going to discuss the hybridization in animals or plants, similarly we have same property. So, desirable characters are we are going to mix. We'll get here desirable characteristics of animal. So, donkey has a one desirable character. Horse also has one more desirable character. When these two are mixed, and we'll get here mule. Mule has a special property of what? So, it has both property of horse and donkey. Clear, friends? So this is called here hybridization. This is called what? Hybridization. Similarly, in our chemistry also we have hybridization that we are discussing today. So here hybridization in atoms. Okay, hybridization in atoms and their orbitals and their orbitals atoms and their orbitals. Okay. Yes. Hybridization atoms and their orbitals. Okay, sir. We'll discuss how they are involving. How they are involving. Same way. We'll discuss. First, we are taking a. We have some types of hybridization. Some types of hybridization. some type of hybridizations. What are those? First one, we know that SP, hybridization, SP hybridization, and second one is SP2 hybridization. Third one is SP3 hybridization. Fourth one is SP3D hybridization. Fifth one is SP3D2 hybridization. And the sixth one and last one is SP3D3 hybridization. These are the most important hybridization in our atoms. Okay, students, and molecules. We'll discuss one by one. What is the hybridization? First one we'll take here SP hybridization. SP hybridization. SP hybridization. Clear? What is SP hybridization? How atoms are involving in SP hybridization? All of you concentrate. Here, one S orbital. Which orbital? S orbital and one p orbital. P orbital intermix. Intermix. What happened here? Intermix and form sp hybrid orbital. Sp hybrid orbital. See here, one s orbital of atomic orbital, one s orbital of atomic orbital, a p orbital of atomic orbital. Both are intermixed and form what? Sp hybridization. Sp hybridization. So, for example, how to understand this one? Sp hybridization by taking one molecule. Yeah, we'll take here best example. Best example to understand sp hybridization. I am taking that is beryllium chloride. Beryllium chloride. Beryllium chloride I am taking to explain sp hybridization. All of you see here carefully. Beryllium, beryllium, atomic number 4. Electronic configuration 1s2, 2s2, and one more valency 2p0. This is the electronic configuration of beryllium. This is ground state. This is ground state electronic configuration of beryllium. Clear? That is up to here. You can see up to here. This is your core electrons. This is your valency electrons. Valency electrons. Okay, students. We are taking valency electron. So this in this core electron, how many electrons are there here? Valency means 2. Core means 2. So that is here. These two core electrons are not participating in chemical bond. We are taking only valency electron. Now in valence electron, we have here 2 electrons in s orbital, and remaining we can see in beryllium. This is p orbital. This is p orbital 1, 2, 3. So how many electrons are? Nothing is there. Vacant orbital. So in ground state, this is what? Ground state position. Ground state position. Clear, friends? Now I am taking in excited state. What appears? One electron of 2s is promoted to p orbital. Which p orbital? This is 2px. This is 2py. This is 2pz. 3 orbitals. What happened in ground state, excited state? In excited state, see, when this electron is promoted to here 2p orbital, then automatically in 2s orbital, in 2s orbital, only one electron is there. And in p orbital, that is 2p orbital, we can see here one unpaired electron is there. That is 2px1. Now we can see here 2s orbital and 2p orbital, 2s orbital and 2p orbital intermix. What are the name? These are here intermix. And from here ESP hybridization. ESP hybridization. ESP hybridization. So what are these orbital? Atomic orbital. Which atom? Beryllium atom. Which atom it is? Beryllium atom. Once again you see atomic number 4, electronic configuration, valency, and here two electrons are in s orbital. No, zero electrons. This is in ground state, isn't it? It is in ground state. But in excited state, we can see that is a one electron is promoted from 2s orbital to 2px orbital. So total number of unpaired electrons in s orbital is 1, p orbital is 1. So these two atomic orbitals intermix and form sp hybridization. This is just to we are taking an electronic configuration hybridization. Now we'll go for your orbital diagram. We are discussing about orbital diagram. All of you concentrate. Orbital orbital diagram. We are discussing orbital diagram of sp hybridization. sp hybridization. I am taking same way. You know, this is a s orbital of 2s, right? This is your p orbital, that is just now written 2px. These two are intermixed. Whatever here, intermix, intermixing. You can say intermixing. And what happened in here? These two orbital intermixing and form a such type of hybrid. This is hybrid. This hybrid is intermixing of atomic orbital. Which orbital? Atomic orbital. Intermixing of atomic orbital. And from here, ESP hybrid orbital. SP hybrid orbital. SP hybrid orbital. Of what? Of we are discussing beryllium. Atomic orbital of beryllium. Clear? Okay, up to here clear. Now what happen you see? This hybrid, we can see this hybrid, whatever hybrid just now we taken. This hybrid here, this hybrid again interact with the see what we need to discuss beryllium chloride, isn't it? What we are discussing beryllium chloride. So two chlorine atoms interact with the two chlorine atoms. You know chlorine atoms are p block elements. Chlorine atoms are which block? P block elements. Therefore this is also like a p. So how many chlorine atoms we are taking? Two chlorine atoms we are taking. These chlorine atoms are nothing but here, or we can take two chlorine atoms. This is also p block. Intermix, or we can say this is overlapping, clear? Overlapping with the hybrid of beryllium. Hybrid of beryllium. Okay, which hybrid it is? Sp hybrid of beryllium. What happens, friends? Now we'll get here. Same, this orbital is same as it is. This is a hybrid of this one. Now this one of the p orbital of chlorine one side, another one is another side. Like this, here you can see overlapping. What happened here? Overlapping taking place. This is a overlapping of this one. Here, this overlapping will give you sense that very important. See, this is the similar to this one, similar to this one. Middle one is this dot indicate what? Beryllium. You can write here beryllium. And this one bond is formed due to overlapping. This is chlorine. What is this? One more bond is there. This is also chlorine. So this is the structure and molecule of beryllium. It formed by the overlapping. So this is we can write BeCl2. PCl2. Now these hybrid contain what type of bonds? What are these things? We'll discuss now. See this hybrid. Which hybrid is beryllium chloride with the hybrid of this one. Can see all of it. This one. This hybrid contain shape is with the beryllium chloride. The shape is linear. What is the shape of this molecule? How we can see? The shape is linear shape. Linear shape. Okay. What is the shape is linear shape. And what is the bond angle here? Linear shape means what is the bond angle? Yes, bond angle linear means 180 degrees. So this molecule bond angle is 180 degrees. And how many hybrid orbitals are there? And this is here actually hybrid of beryllium, hybrid of beryllium, that is will form sigma bond. So sigma sp2. This is p orbital. This is p. Here also we have sigma, isn't it? Sigma sp sp2 p orbital. Like how many sigma sp2 p orbitals are p bonds are there? 2.
Okay, students, this is today's class. Tomorrow we are going to continue our another class. In that class we are going to discuss what are the questions will come in a examination, what are the tricks for us, all these things. Thank you very much. Please subscribe.